we are working with inverse functions. So what I would like to know, remember that this is an xy coordinate. So in this case, the point 0, 7 is on my original function, which means if I look at the inverse of this function, then the point 7, or the x-coordinate of 7 on the inverse, will produce a 0 on the inverse. Okay, so that means that the point 7, 0 is on the inverse. If 0, 7 is on the original, 7, 0 is on the inverse. Okay, so look at this. This means 3 comma negative 9 is on the original. So my xy coordinates are going to flip-flop for the inverse. So if 3 produces a negative 9 on the original, then negative 9 will produce a 3 on the inverse, because the point negative 9, 3 will be on the inverse. Your x's and y's flip-flop. They don't change signs, they flip-flop. So your answer on this one is going to be 0. Your answer on this one is going to be 3. So looking again, what I have is the point on my inverse is negative 4, negative 2. So this point is on my inverse. Well, then what point is on my original? I flip-flop my x's and y's. So given that x is negative 2, what would my y be? My y would be negative 4, because the point negative 2, negative 4 is on the original. If the inverse has negative 4, negative 2, then the original had negative 2, negative 4. And then finally, if the point or the x-coordinate on the inverse is 9 and it produces a 5, then what point will be on the original? Well, 9, 5 is on the inverse, so 5, 9 is on the original. So this would be 9, 5, and then I flip-flop my x's and y's. So again, this solution is negative 4, and this solution is 9, because you are flip-flopping your x's and y's. So now I want to go forward and I want to see and test to see what the inverses are. Okay, I want to verify, I want to verify that these two functions are inverses of one another. So as I look at this, my process is going to be, I'm going to find f of g of x, and I'm going to find g of f of x. And when I simplify, both of those need to reduce to just x. Both of those need to reduce to just x. If they both reduce to just x, then I'll end up verifying that these are truly inverses of one another. So the first one I'm going to do, f is in charge. So I have, let's do him in purple. So I have a negative 3x plus 5. And then I'm going to put g of x inside of it. So here's my negative 3x plus 5, but I'm going to hide g of x inside of it. So this is a negative x minus 5 over negative 3. And now I'm going to simplify. So as I simplify this problem, let's find red. Okay, what happens over here? Negative 3 and negative 3 reduce. Any number divided by itself is 1. That leaves me with a negative x minus 5 plus 5, which leaves me with a negative x. Okay, so now I'm going to go backwards. Now I'm going to go g is in charge. So I've got a negative x minus 5 over negative 3. So I have negative x minus 5 over negative 3. But wherever that x is, I'm going to put what f of x was. So g is in charge, nest f of x is inside. So I get a negative 3x plus 5. And now I'm going to simplify again. So I'm going to distribute in the numerator. So that's going to give me a negative times a negative is going to be a positive 3x. That's going to turn into a negative 5. And then I have minus 5 over a negative 3. So this is not going to turn into just an x. So this one failed because it gave me a negative x, so I could have stopped there. But this one, when I simplify, gives me a 3x minus 10 over negative 3. And so that one is as simple as possible. And so he also fails. So these are not inverses of one another because they should have both produced an x when I simplified. And for our last example on the play posits, I want to know if the given function has an inverse, and if it does, what is it? So I'm going to rewrite this as f of x equals a negative 2x plus 2, which should tell you it's a diagonal line. He slices through the y-axis at 2, and then he drops with a slope of negative 2. So I already know he's a function. He passes the vertical line test. Does he pass the horizontal line test? Yes, he does, which means he does have an inverse function. So let's go find it. So my inverse function, I'm going to rewrite this for a third time, and it says y equals negative 2x plus 2. But in order to find the inverse, I'm going to flip-flop my x's and y's. So this now becomes x equals negative 2y plus 2. And now I'm going to solve. Okay, so I'm going to get y by itself. So how do I do that? I subtract 2. So x minus 2 equals a negative 2y. And then I'm going to divide everything by negative 2. So this is going to become a negative 1/2 x. This is going to become a plus 1, and that's going to equal y. So you're used to seeing it in that method, or in that format. So this is going to be the equation of my inverse. So now I can rewrite it a final time, and I can say this is the inverse of my original f of x. That is now the inverse of my original f of x. So just for kicks, let's graph it. I have a y-intercept at 1. So here's 1, and then my slope is down 1, right 2. So I'm going to go down 1, right 2, down 1, right 2. So then I have this graph like this, which is not perfect, but that is the graph of the inverse. And what's your bonus? It is symmetric across the line y equals x. And that is it.